it's recording. Okay, so booting is the process between the powering on a device and loading of OS. Okay, so there are 6 stages in Red Hat Linux 6. Okay, the first stage is BIOS, basic input output system, and I will tell one by one. Okay, second one is MBR, master boot record. Third one is grand unified bootloader, Grub. Fourth stage is kernel. Fifth stage is init. Sixth stage is run level. This is somewhat different from RHL 7 version. It is for 6 only. Okay, the first stage, BIOS is nothing but basic input output system. It is the first program that is executed by our system after powering on the device. That is called post powering on the system utilities. uh, this is called firmware. Firmware is nothing but it is a program. Okay, BIOS firmware, it is called BIOS firmware. Okay, it will load. What it will do is it will perform some system integrity checks. Okay, what it will perform is it will check whether all the after powering on the devices, it will check what are the input output devices are available. Okay, it will check. That is a program. Generally it is called firmware. Okay, firmware basic BIOS, the same in Windows also. So what BIOS do is it will perform system integrity checks. After that it searches, loads and executes the bootloader program. So this bootloader program is responsible for all the booting process. So after powering on the device, the basic BIOS will check the system integrity checks, will perform the system integrity checks. After that it will searches where the bootloader program is. After searching it loads that program and executes the bootloader program. That means it will give the control to this bootloader program. Okay, after powering on this is the first stage. BIOS is the first stage. BIOS will search and loads and executes the bootloader program. So generally how it checks the bootloader program is it will check the hardware drives like floppy, cd-rom or hard drive. Okay, of course most of the cases it is hard drive or hard disk. Okay, these cd-rom are temporarily. If you want to load the OS temporarily, then it will check floppy or cd-rom. Okay, these are uh, not general. Hard disk, generally the bootloader program in the hard disk. Okay, it is located in the first sector of your hard disk, first hard disk. Okay, so if you press a key F12 or F2 during the BIOS startup, you can change that boot sequence. You know, this Windows you often do this. Or if you want to change that booting sequence, you can disturb that boot BIOS startup by using F12 or F2. Okay, once if the bootloader program is detected, that will load it into the memory. BIOS gives the control to it. Okay, initially BIOS will checks the system integrity. Okay, whether all the input out devices are there or not, it will check. After that, BIOS is also a program, it is a firmware program. After that it will check for bootloader program, where the bootloader is. Generally the bootloader program is located in the first sector of your hard disk. It will detect it and loads it into memory. Okay, after that once it is loaded into memory, it will give the control to the bootloader. Okay, simple if you want to sell it in simple terms, BIOS loads and executes MBR. Okay, so the MBR is the second stage of your booting process. So MBR stands for master boot record. Okay, the name itself tells that it is a record. That means it tells where the bootloader program is, where that bootload, how the sorry uh, uh, where the bootloader program is. Okay, it will point to that. It is located in the first sector of your bootable disk. Bootable disk means from where that bootloader program is. Okay, so generally bootable disk means generally it is hard disk. Sometimes it may be floppy or cd drive. So The portable disk, generally we will naming sequence will be like this: slash dev HDA slash dev SDA. If it is SCSI, it is this. If it is IDE drive, it is the naming sequence like HDA. If it is SCSI device connected to the SCSI controller, it is SDA. Okay, like that. If it is some VM, then it is slash dev VDA, like that. The sequence will be like that. So the first disk is always represented like this. Okay. Okay, MBR is nothing but master boot record. It is located in the first sector of bootable disk. So generally the bootable disk will be named like this: slash dev HDA slash dev SDA, like that. Okay, SDA for the first disk. So it is always located in the first disk. So SDA, the naming convention like SDA, STB, STC, like that. Is SDA for first hard disk. Okay, so that means it is always located in the first sector of our bootable disk. Okay, next. So generally MBR is less than 512 bytes. MBR is also, it is a program. Okay, 512 bytes in size. Okay, this again was divided into three parts. The first one is primary bootloader information. Primary bootloader, okay, information. In first 446 bytes, it consists of that primary bootloader information. So which bootloader will load into the system, that will be given by this one. Okay, the information about the primary bootloader was located in the first 46 bytes of your MBR. So total it is having 512 bytes. In that 512 bytes, the first 46 consists of this. Okay, after that the remaining after that the next 64 bytes occupied by that partition table info. Okay, information, partition, PTI, it is called PTI, partition table information. Already, at the time of partitioning, we'll always do only 4 partition was allowable in our Linux. Why it is so? Because if you see, so the partition table information stores the where the how many partitions are there, entire information about that partitions. So every partition is identified by 16 bytes, 16. So 16 into 4 only. So four partitions only can be allowed into this partition table, because 4 into 16 equal to 64. That's the reason you can do only 4 partition in this Linux. Okay, for that reason we are having 3 primary partition, 1 extended partition. Again, that for our convenience, that extended partition can be divided into logical partition, so that we can do number of logical partition. Okay, but on the overall externally, if you see that, it will the partition table table only consists of can allow only 4 partitions, because the size of each one has 16 bytes. 16 into 4 only, it will allow 4 only. Okay, next, after that 446 plus 64 is equal to 510. The remaining two bits are for MBR validation check. It is called magic number, some magic number to identify that MBR. Okay, to identify that number. So the remaining 2 bytes are for that MBR validation check. Totally 512 bytes for MBR. So what MBR knows is, it contains the information about Grub. Grub is nothing but Grand Unified Bootloader. So primary bootloader program is that is. So for 5 and 6 it is called Grub. For 4 in old systems, 4 or before 4th version, it is called LILO, Linux loader. Okay, in old system it is known as LILO. The primary bootloader is LILO. So on 5 onwards it is known as Grub, Grand Unified Bootloader, the third stage. It is the third stage. So in simple terms, MBR loads and executes Grub bootloader. Okay, so the first stage is BIOS. What BIOS will do is, it will checks and it will searches for MBR and loads MBR, and and executes mbr. That means it will give control to mbr. What mbr will do is, in simple terms, it loads and executes grub. Grub is the bootloader. Okay, next step is next stage is grub. Grub stands for grand unified bootloader. So what grub will do is, it is the first software program that is executed by our system. Okay, before that one is BIOS is a firmware. It is not like software. Okay, firmware is comes with hardware that is written for hardware, which hardware is connected, which is not there. Okay, mbr is just like a record. It will contains the information about where the bootloader program is. Okay, and partition table information, where the partition table information is. Okay, so grub is the bootloader program. Okay, if you have multiple kernel images, but that means in linux, in the system, in the linux os or linux, you can have multiple kernels. You can load with different you can have different kernel images installed on your system. You can choose which one to be executed. That means you can have different kernel images like 2.6, 2.8, 3, 3.10, okay, 4.8, like lot of kernel images are there. If you can install multiple kernel images on your system, you can choose which one you want to do. Okay, so that information is in grub. Okay, if you want to choose which one, that can be chosen from grub only. I will show you how to do that. Next, grub displays a splash screen, waits for few seconds while booting. You will get some splash screen. Okay, it will wait for some seconds. Okay, if you don't disturb that screen, it loads the default kernel image that was specified in your grub configuration file. I will show you now how much time it will wait. That also we can decide. We can set it in grub configuration file. Okay, with which kernel image we need to load the system is, we can decide in grub configuration file. So that configuration file is located here in /boot grub.conf. Everything is in this file. Based on the configuration in this file, the grub will decide which kernel image we need to choose, and how many seconds it has to wait while booting that. Okay, next, grub has mm, grub has knowledge to understand the file system. In older systems, that facility was not there. That means in RHL4 before versions, they don't, that LILO, the name of bootloader is LILO. LILO, Linux loader, doesn't understand the file system, whereas grub can understand the file system. That is the updated version compared to Lilo. Okay, so the configuration file for grub is grub.conf. I will show you what is that grub.conf. I will show one by one. Okay, next stage is, next one is kernel. So kernel is heart of the system, your operating system. So what kernel will do is, it mounts the root file system as specified in root equal in grub.conf. We will specify what is that root file system. Based on that, the kernel mount that system. Okay, kernel executes the init program. So init program is the first process in our executed by our OS. Okay, so init program is in spin init. Okay, so init was the first program executed by our Linux kernel. The process ID for that initrd is 1. So I will tell you what is that process ID. Every process in Linux is identified with a ID. Okay, that is nothing but PID or process ID. Okay, so based on the process ID, the kernel will execute all the processes. Okay, so if the process ID is very lesser, it has highest priority. Okay, so init is the first process we need to execute. That's why it is, the process ID is 1. If you want to see that, you can see that by using ps-ef grep init. I will show you. Okay, so before doing that, before executing before executing the what kernel will do is it will mount that root file system. Okay, before doing that, what it will do is it will mount a temporary file system that is known as init ram, initrd. Initrd stands for initial RAM disk. Okay, what this initial hard disk is, it is a temporary root file system until kernel is booted. Okay, so before kernel is booted, it will load init RAM, initrd, init RAM disk. Okay, so what it contains is, it contains the necessary drivers compiled inside, which helps to access the hardware partitions and other hardware. So if you want to boot it, it needs to access the hardware now. So if you want to access the hardware, you must have some drivers, you know, Windows. If you want to access some cd-rom or something, you must install the drivers. If you don't install those drivers, you cannot access the hardware. In the same way, before loading the kernel, initrd will act as a temporary file system. It has some drivers. These drivers can be useful to access the hardware partitions, so that later kernel will mount the original root file system. Okay, the purpose of this initrd is, it is acts as a temporary root file system to load kernel up to kernel booted. Okay, so what kernel will do is, it will mount the root file system and it will execute the next stage. Fifth stage is init program. So init is the first program, the first process that is executed by our kernel. So it is the first process. It is the mother of all the processes. Okay, whatever process you see, the every process is the mother, is the child process for this init. Init is the parent process for all the processes. Okay, so if you want to see what in init, the following in Linux, the following run levels are available. So there is a file called initrd, that is in /etc initrd file. Which run level we want to on, that will be decided by this file. So there is a line with the id equal to some value. Based on that id value, it will load the run level. Okay, so what are the run level that are available in Linux is, there are seven run levels. So in Linux, RHL 6, those are called run levels. In 7, those are called targets. Okay, so the first run level is known as 0. First run level 0 is halt means stop. Okay, you know, halt. Okay, if you execute init space 0, all the process will be halted. So next, run level 1 is single user mode. So if you enter in run level 1, it will allow only one user. Okay, single user mode. So in this single user mode is obviously that is root. Okay, so to recover or rescue the OS, will go generally into this single user mode, that is run level 1. Run level 2 is multi-user mode, but without NFS. I'll tell what is NFS. Network file system. Okay, network file system. So if it allow multi-users in run level 2, it allow multi-users, but it doesn't have NFS. Okay, in run level 3, run level 3 is full multi-mode mode. That means here all these NFS, all these allowable. So in real time, we'll go with run level 3 or run level 5. Okay, almost all the systems in real time are run level 3. So there is no GUI executable, only command line interface only available in run level 3. So next, run level 4 is not used, and run level 5 is similar to full user multimode, but it will allow some GUI. Present our lab is in run level 5 only. I will show you. Next, last one, 6. Run level 6 is reboot. If you execute init space 6, then our system will reboot. I will show you one by one. So init defines the default init level from /etc init tab and uses that to load all the appropriated program. Okay, so if you want to see what is our default run level, you can see that by this command grep init default /etc init tab, or you can see that by using simply who space -r. By that command also you can see which run level are we are in. Okay, if you want to make something like that, some trouble, you can go with 0 or 6, but in real time don't do without any knowledge. Okay, without any approval. So generally we don't to go with 0, 6 to reboot our OS, 6, but in real time if you go with the run level 6, you need to take a proper prior permission. Okay, without permission, if you do that, it will affect our business. Okay, that is you must take care of it. Okay, so generally our run level is 3 or 5, but for practice session we will use 5. You can use the 3 also. In real time 3 only allowable. Okay, that is fifth stage, init stage. So what init will do is it will load the run levels. Which run level will, so that run level information, which run level you want to load is that was given in this file /etc init tab file. So init is the first program, that is parent program, mother program of all the other mother process for all the other processes. Okay, it is a parent process for all the processes. So what init will do is it will load the run level. How it will load the run level means, for run levels are also nothing but they are programs. Those are also run level programs. Okay, so where it will load is, you are having a directory in /etc that is called rc.d. In rc.d again you are having 7 directories: rc0.d, rc1.d, rc2.d, rc3.d, like that rc6.d. There are 7 directories in rc.d /etc. In /etc you are having a rc means run level. Okay, run level. Okay, rc.d. In that again you are having 7 directories. Okay, so if you go with the run level 1, then it will execute the program in these directories. Okay, I will show you what are those. If you go with 3 run level 3, that will go here where these run levels are specified. Those already I told you here in /etc init tab, the run level number is specified with id. I will show you. Okay, whether if it is given in that /etc init table it is 3, then directly the kernel will load, the init will load these programs /etc rc.d. In this directory you are having these programs. Some programs are there. rc3.d directory you are having some programs that will load all those. If it is 5, run level 5, it will load all those. Okay, so when you execute init space some 6, it will go to this directory and execute the programs inside it. Okay, like that run level programs will execute. Run levels are nothing but those are the programs. So we'll see one by one what are those. So okay, first which one, you see one by one. BIOS I will show after rebooting it. BIOS I will show later. This time BR also cannot be seen. Grub I will show about information about grub. The total information about the grub is here: /boot/grub grub.conf file. In that file we are having the information about the which kernel we want to load with, and how much time the kernel has to splash screen will be there. Okay, the similar file, there is a link for this file. This is the original file. The link for this one is, symbolic link. Okay, this one /etc grub.conf. Okay, in /etc there is a file. Okay, and the same file, this is the original file. For that the file is, why they will maintain the link is, they're maintaining some backup like that. Okay, so go to slash, or directly see the contents of that file: cat /boot grub.conf. okay, look here. So what is the information we're having inside this grub.conf? So grub.conf generated by anaconda something. Okay, like that. Okay, so look here, root So hd naught means our hard disk in the first sector. Execute that one. Kernel and our VM Linux version. Our version is VM Linux version. Look, if you look here, initrd. Initrd is a temporary root file system. Before loading kernel, it will install all the drivers to execute the partitions. Okay. And if you see here, boot, where bootloader will be there means boot equal to /sta. So from this first hard disk, always it will take the bootloader from this first hard disk again in that first sector. Okay. So here it is saying that default equal to 0, which means default kernel. It is asking for which kernel image you want to load with. So default equal to 0. 0 means if you see hd0, if you see here hd0 of 0, so this is the default kernel image, Red Hat Linux 2.6. This is the first kernel. Of course I'm having only one kernel image here. Okay, that's why it is taking the default. If you have two more kernels are there, after that it will there one with some number 1 2 3 like that. Okay, if you want to load with the new kernel, another kernel, then it will we can give the number here. If you have two more images are there, two more kernel images are there. Okay, this is the kernel. Right now I'm having one kernel. If you want to change the another kernel, you can install the kernel and you will give the number here. Okay, whatever it may be, after installing new kernel, the latest kernel will go to the first place. Okay. Next, timeout. Already I told you now, whenever we're after BIOS, there is a splash screen. The splash screen will be for some time. The timeout is this one. 5 means 5 seconds. It will wait for 5 seconds. If you disturb that screen with uh, by using some key, by pressing some key, then it will go to that grub. Okay, grub level kernel. It will, we can choose the kernel. We can have some options. I will show you. Okay. If you change this time 3 seconds 2 seconds, that also it will doesn't give it will give that time only, lesser time. Okay, if you want to increase the time, you can increase this one. Okay, next, splash image. That splash image is nothing but you see at the time of grub loading. Okay. Next, so these are all the settings of your kernel. Okay, kernel VM line is it is mounting as read only. Kernel is read only. You cannot write, because if you write something into kernel, everything system will spoil. Okay, disturb. Root, where the root is. Okay, everything. Okay, like this. These are, do some research on this one. Okay. Next, initrd, initrams fs. File system name of initrd is initram fs. Okay, kernel is VM Linux. Our present version of kernel is 2.6.3, some versions is there. Okay, this is about grub.conf. In grub.conf, it will consist of okay. So it is this one. So to see about which is the default run level, we can see that by who -r, which run level we are in. So I'm in run level 5. Okay, the same can be seen from a file cat /etc init tab. In this file you're having the information about the run level. Okay, from this. Okay, so read this one if you have some time. At the end of the line, if you see here, id colon equal to 5, my run level is 5. If you change this one, if you change it with 3, okay, so it is init default run level is 5. If we change that with 3, that will load in run level 3. Okay, this we can do. If you change this here, you need to reboot it. Okay, so, or you can do that by this way also. If you execute this command init 3, then also that will change. Okay, check whether which run level we are in, foo-1 or locale run level 3. Again, if you want to go back to our okay, run level 5, again same way. Temporarily we can change like that, but permanent, if you want to change it permanently, you must change it through that file. Which file it is? /etc init tab. If you look here, in run level 3 you don't have that graphical user interface, just only whatever you want to do, you can do that on command line interface only. Mouse doesn't work. Mouse won't work on 5 only, x11 versions only. Okay, again if you check it, /etc init tab, look here. So id equal to 5 init default, so still it is in 5 only. After reboot, again that will load with 5 only, just by using init space 3 command. Just I have changed it temporarily. Okay, but then after next reboot, again it will change. Again I'm going back to init 5. Okay, again look here. So those are the programs that are executed from rc.3. I'll show you rc.3. Okay, again it is going back to old run level 5. So run level 5, if you see it, it is a graphical user interface. Okay, x11, this is called x11. Okay, it's taking time. Okay, check it. foo-1 or run level 5 it is. Okay, but in real time, almost all those are in run level 3 only. Okay, next, go to /etc. There is a file called rc.d, or where it is rc.d. Here, this one, rc, sorry, this one, rc.d. Okay, I'll tell what is this, what are these. Okay, later. So again move to rc cd space rc dot t ls. Look here, in rc.d directory we're having these init.d. We'll see later what is init.d, rc0.d, rc1.d. These are the programs for, these are the directories which consist of programs for each run level. If you go with run level 3, those are executed by this one. If you go with okay, run level 5, those are programs executed by this one. Again go and check it. cd, suppose check it, rc3.d. Okay, if you see here, these are the program, each and every one program, k01 smart ds, k30, small, okay, these are the programs which process you need to execute, which process you need to start. Okay, run level 3. So K means kill, S means start. Okay, so kernel will identify based on that lettering mode. Okay, so rc.d, these are the programs. So if you change to that run level, the kernel will execute all these programs. Okay, go back. If you go to suppose rc, suppose 0 .d ls. Okay, look here, rc did run level 0 is nothing but, what is run level 0? Halt means you need to stop all the process. Okay, so all you're having all start with k, you need to kill all the process. Okay, only two process you need to start. One process is halt process, and second one is kill all. Okay, except that all the remaining process are kill. So that will stop all the process. Like that, whatever run level we choose, based on that the programs will load into here. Okay, that is about booting process. Okay.